biggest fear sometimes is that there are so many substandard products which are already hitting the market at a fraction of a cost, which haven't been vetted, which haven't really gone through the rigorous ways of actually testing it. That sometimes people see it, they buy it, they use it, and they realize that the data is not good enough, and then they lose faith in the entire technology as such. Deep tech takes a lot of time. Even the technology development takes time, and especially if it's a medtech product, it takes even more time because you go through the whole regulatory. We are walking into a lot of aged care homes where there's still pen and paper. And the idea of bringing a computer in and now a dashboard in and then technology in is something which is so foreign. So miniaturizing something smaller and sleeker is not always the way to go if you know the person who's going to be looking at the technology lacks the dexterity to actually kind of look at it, right? It can be the best technology ever, but if no one's going to use it, it's might as well not exist, unfortunately.
Are you looking for high-performance AV distribution that just works? Meet NetVio, a UK-based innovator delivering cutting-edge AV over IP, HD-based T, HDMI, USB, and Dante AVA hardware, backed by intuitive, license-free configuration and control tools. The NetVio 360 configurator and license-free NetVio Go user control app makes setup and user control effortless, while the open universal API and pre-built drivers ensure seamless integrations with Control4, Crestron, RTI, QSYS, and more. NetVio is exclusively distributed in Australia by Chords Australia. Check them out at netvio.com.au. That's netvio.com.au. From the 3rd to 6th of February 2026, ISE, the world-renowned annual tech show for the systems integration and audiovisual industry, returns to Barcelona, uniting the brightest minds and boldest ideas in smart home and building technology. Last year, almost 12,000 professionals affiliated with the residential sector visited the show for a taste of state-of-the-art industry technology. As co-owner of ISE, CEDIA ensures the show remains the leading voice in residential solutions and home automation. Step into the residential and smart building technology zone at ISE, where visionary concepts meet real-world integration. And don't miss CEDIA's world-class education program, designed to give you the insights, skills, and techniques that are shaping the future of integrated living. Don't just keep up with the industry, push beyond and get ahead of it. Join us for ISE 2026 in Barcelona, and use our special code, Master Integrator, for free registration at iseurope.org. That's Master Integrator as one word at iseurope.org. Today's cinema clients expect more, and with Colosseum, you can deliver. Through the company's new Spark program, when a vendor opts in, a dealer can get Colosseum-designed cinemas at nearly half price. Spark shares the load between dealer and distributor, cutting your costs and creating stunning, immersive designs, including 3D panoramic room tours that drive upgrades and close deals faster. Less wholesale cost, faster sales, Colosseum, the design and documentation wingman you didn't know you needed. Hello and welcome to Master Integrator, the podcast that explores the future of living through the lens of smart home technology. I'm your host, Paul Skelton. Before we kick off today, I'd like to thank my growing stable of sponsors and supporters. NetVio, which is exclusively distributed in Australia by Chords Australia. Colosseum, the design and documentation wingman you didn't know you needed. Connected Magazine, your go-to resource for the smart home, commercial AV, and integration industries. Integrated Systems Europe, or ISE, the world-renowned annual tech show for the audiovisual and systems integration industry. And CEDIA, the Association for Smart Home Professionals. Without their support, this show wouldn't be possible. So be sure to show each of them some love and get behind what they're doing locally and globally. Now, typically I jump straight into an interview with someone, but I'm going to mix things up a bit. Today, I'm launching a new segment called Paul's Rant, because I know you, and I know the one thing you all want more of is me speaking. The goal here is to let you know what it is I'm working on in the background. And today, let's talk about the forthcoming census. Fascinating stuff. A few months ago, I posted on LinkedIn about the importance of calling yourself a smart home technology integrator in next year's census. Of course, for anybody who works in our industry, you would know that we are drastically underrepresented and unrecognised at the government level, and the only way to fix that is to gain recognition as an occupation. Of course, a few people took umbrage to the very idea of calling themselves a smart home technology integrator because it somehow didn't align with the work they do of integrating smart home technology. So let me set the record straight. I honestly don't care what you call yourself when you're talking to your clients. It doesn't affect me in the slightest whether you call yourself an integrator, an installer, a technician, or an AV unicorn cowboy. Actually, if you do call yourself an AV unicorn cowboy and make a living, let me know. You may be a marketing genius and we should have you on the show. But my point is, you can call yourself whatever you want, just not on the census. I'm not here to start a debate on what integrators could or should be called. I'm trying to get an occupation code so the industry can access government incentives and insurance programs. And the way we do that is by having everybody in the industry use this very specific term, smart home technology integrator. And your clients will never know. Do you think security technicians walk around calling themselves electronic equipment trades workers? No, of course they don't. But that's the occupation code they fall under. So if you got miffed about my post, calm down. Everything will be all right. But at the same time, it won't be all right if you don't call yourself a smart home technology integrator at next year's census. So please, whether you're a business owner, designer, installer, admin worker, write your occupation down as smart home technology integrator. Not technician, not installer, not AV guy, not manager. Smart home technology integrator. Occupation data drives recognition. If we want to be acknowledged as a distinct profession, if we want apprenticeship pathways, insurance reform, government support, we need to show that we exist. So smart home technology integrator, tell your team to do the same and help move the needle for the whole industry. Now, on with the show. Today we're talking about wearable technology. If you've ever brushed wearables off as a gimmick or wondered how close the body technology should actually get, today's guest will help shed some light on the topic. I'm joined by Professor Madhu Bhaskaran, co-leader of the Functional Materials and Microsystems group at RMIT University in Melbourne. She and her team are developing skin-like sensors, biosensors, and Nearables that are reshaping aged care, preventative health, and human-centered technologies in ways that most of us are only just beginning to grasp. Imagine a mattress that can alert carers to a fall risk, or a flexible patch that monitors your ECG without interrupting your daily life. Or how about a saliva-based diagnostic that provides blood test quality data without the blood? These aren't sci-fi concepts. They're already being trialed in the real world. So we talk about why user feedback must drive design, how cultural attitudes towards privacy shape adoption, and what integrators need to think about when these technologies start entering the home. This is Master Integrator. Here's Professor Madhu Bhaskaran. So, welcome to the show. Thank you for joining me. So let's begin right from the start. I mean, how did you actually first get into this world of wearables and Nearables? And if you're also able to explain exactly what a Nearable is, I think that would be quite helpful.
Good question. So I'm an electronics engineer. So I'm a professor of electronics engineering at RMIT University. A lot of what we do is predominantly looking at smart materials. So looking at how materials can be integrated into making everyday technology devices. And for us, one of the key goals for our research group actually is turning science fiction into reality. So at one point in time, we started developing these kind of cool technologies within the lab, which allows you to put electronics on a contact lens type material. So really thin, really flexible, transparent, which adheres to your skin or adheres to your clothing, and therefore you don't really feel yourself wearing it. We kind of left it to be more industry led in terms of the potential applications for this technology. Um, I always anticipated it'll sit more in the wearables space, so where you might want to put technology on clothing or on your skin and monitor something which is happening. But funnily enough, our first ever industry partner was actually a company called Sleep Tight, who came over to us and wanted to actually put sensors on mattresses. And the entire idea there was trying to put sensors on mattresses so that people can actually use them in residential aged care homes and to monitor what's happening during the course of the night, right? So is a person in bed? Are they at the risk of falling out of bed? What's their posture on the bed? The biggest thing which you're trying to prevent is a fall from occurring, especially in aged care homes. So that technology where, you're not wearing the technology, but you're near the technology is what we call a nearable. So there's no real obligation on you to wear something, charge something, remember to do something. The entire idea is the technology is there and you get on with your life as you always do, and the technology does the rest for you.
Okay. And I guess that is an application that a lot of people probably hadn't considered and yet neither, especially within kind of aged care and aging in place. And it is a very big, significant market. So I'm wondering, I guess, what is the full potential then of your research within this space? Obviously, you mentioned the mattresses, but I imagine it can go beyond that as well.
You mean within the aged care space?
Within the aged care space.
Again, you don't have to restrict yourself to Nearables, right? I mean, even with the wearables which we make within our labs, a lot of them can monitor so many different health parameters. Like, for instance, we are making various kind of sensors which kind of you wear on your skin. It's monitoring your ECG on a continuous time period over a 12-day or 14-day period. Some of these are looking at skin temperature fluctuations. Some of them are looking at oxygen and oximetry variations. These are all like key infection parameters, which anybody looks at in an aged care setting. So in fact, one of our other cool technologies, which is more in the wearable space, was actually trialed by the NHS in UK in aged care homes. And the entire idea there was, especially during COVID, you had to take these 3 measurements every day, at least 3 times a day, of the people in the aged care home. So you had to measure their heart rate, you had to measure their skin temperature and their oximetry. It took every nurse 7 minutes every time. So 3 times a day, 7 minutes every time to get this information off the people. And obviously during COVID, you didn't want to be too close to the person, touching them and poking them and prodding them. If someone has dementia in their aged care setting, it took them up to 25 minutes to do this every single time. So the idea at that point in time was trying to use wearables and wireless electronics to kind of get this whole thing done, where you don't have to keep going close to the person and touching them and making these measurements. Literally apply it as like a sticker onto them, and hopefully the technology conveys the information through the Bluetooth onto the cloud, and there the clinician has all the data to make all that decisions. So there are various shapes and forms technology can take in these aged care settings. It's just a matter of what are you looking at monitoring, I guess. But at the same time, for us, it's also come from a heavy user and design perspective as well. Like especially the Nearable, which I mentioned, which was the technology of sensors going on mattresses. The biggest feedback we got from a lot of aged care staff was, don't add elements of or layers of work to our to our already busy schedules and already busy lives, right? So it basically, you don't have to make something so complex that somebody has to remember to do something different, because they probably would do it for a week and then they'll forget about it after that. So that was the entire user feedback. And so we keep that in the back of our mind every time we develop new technologies.
So I guess when most people think about wearables, they think about smartwatches. Really, I mean, that's probably the main kind of thing that comes to mind. So when you're talking about the actual wearables that you're developing and the technology there, how is that different from those kind of consumer grade products that are already available? Will it look the same? Will it act the same? Is it just an extension of that? Or are we talking about something completely different?
I would almost call mine more tattoo-like, right? So much thinner, which you don't literally, and even with a watch, right? Like for instance, a smartwatch which you mentioned, there's still that element of having to be careful with it. There's still that element of, I shouldn't knock it on something and it might crack or it might not work. And secondly, and most importantly, it doesn't really give you reliable data. So it collects data, but how reliable is it? And how can you actually make decisions, clinical decisions, especially on the back of the data? You definitely can't. My biggest joke is, according to my watch, which I've been wearing for 4 years now, I'm clinically dead, right? So my oximetry levels, according to that watch, is 76% or something dismal. So the entire idea for us for these wearables is to keep them much thinner and keep them much more reliable, which is what takes us a lot longer to get it to the market, because we have to go through all the regulatory aspects which you go through so that people can reliably use that data to make clinical decisions of it, which you can't really do from the current smartwatches, unfortunately.
So you obviously mentioned that your background being an engineer. Were you always interested in applying, I guess, engineering concepts to the space of health? Was that always on the radar, or is it really something that you've then had to kind of embrace and learn on top of what you were already doing from a technology perspective?
No, I don't think we ever had health in the forefront of it. I used to make materials. So I think I came at it more as an electronic materials engineer. So it was more of what are the cool materials and how can you use these cool materials for various new applications. We used to do a significant amount of gas sensors, for instance, for mining applications or for defense applications. We used to do UV sensors, which again are quite useful, which are quite versatile. So whether you're looking at something disintegrating as a result of UV, or whether you're looking at someone monitoring their UV so that you go and know when to go put on more sunscreen and things like that. I think somewhere it kind of just migrated because of the industry interest which was coming in the entire medtech space more in this area. Like I always say, the technology is actually quite agnostic when it comes to applications. Like there's no reason why we can't use very similar technologies for sports tech or for defense or for ag tech or for space tech, right? It's pretty much the similar kind of things which sit across a lot of them. So they're not really dual use technologies. Some of them actually quadruple use technologies. It's just that somewhere there's been a massive interest in medtech, and the entire startup culture seems to be more medtech focused. COVID, I think, kind of refined that a lot more as well because people suddenly kind of understood how important health is. And for us, I think it also comes at a more of a preventative health angle, right? So it's not about getting a disease and now thinking, now what do I do and living with that disease? It's looking at it more from the perspective of trying to get an understanding of your health parameters so that you, I don't know, exercise better, eat better, so you don't actually land up in that situation of having that disease.
It's quite funny because from our industry, I mean, we're working at the moment on building an apprenticeship program, which has never existed before. And there's always been some interest in it. But when we started talking about the aging in place and the disability applications of technology, all of a sudden we have full support in what we're trying to do and get it over the line. So there is definitely a focus on that at the moment, which has been, I guess, quite positive. It's gotten results, but yeah, it's just amazing that there is that kind of synergy between what we've been doing, even though it's completely different. You mentioned some of the other potential applications there, whether it's defense, space, sports. I guess, what is the full potential of the technology then in terms of what you're looking at? It sounds like it could potentially be applied to any industry and kind of for a different purpose.
It depends on what aspect of it, right? So even the health ones, which I mentioned, like where you're measuring your ECG or your skin temperature and things like that, those are pretty much similar parameters which you want for somebody in a defense setting as well, right? You want to understand the health of the soldiers. Actually, the same thing kind of goes to Nearables as well. So where you're putting Nearables in aged care setting, in some ways, it also helps you monitor your quality of your sleep, which you've had overnight, because you know how much a person's tossing and turning during the course of the night with the help of these sensors, which in turn kind of, again, aligns to a defense setting because you know how alert a person is going to be the next day as a result of the good sleep they got the previous night. And similarly, with the all the other health parameters, for somebody who's actively, participating in sport, that is something which is quite nice to have as data, which is understanding what your health parameters are as you're running around playing sport. So those are just the health which can be transferred across in terms of other applications. But the electronics per se is actually quite tiny and miniaturized. The ability to have wireless electronics that goes across a lot more applications. So if you have a gas sensor, which is say attached to a plant, like a plant wearable of sorts, the same miniaturized electronics, which kind of allows you to gather the data and send it off via Bluetooth to the cloud, is the same platform which you use for our ECG and for our other healthcare as well. So even though sometimes the core sensor might change, the core miniaturized electronics aspect of it sits across quite a few different industries.
So what is, I guess, the core product or system or what you've actually designed? That is the technology. Are you looking at ways to then apply that in completely different environments? So not just necessarily this kind of stretchable skin-like material. Are you looking for other applications where you can, I guess, apply that technology?
We totally could. Like I said, we've just kind of been more industry led in terms of, where we want to apply this. It's funny because when I started doing this, and it was nearly a decade ago, I thought my first ever industry partners would be defense for monitoring, gases
Mhm.
or explosives. I thought it'll be mining companies because they might want to know what's happening inside a mine when a person is encountering, say, a odorless, dangerous gas. And I thought maybe because, unfortunately, in Australia, we have so much skin cancer, people would be super interested in the UV sensor right? So that you know exactly how much UV exposure you're having on a day-to-day basis, and then you know when to go and put on more sunscreen. And there was also another interesting thing, which was where the amount of vitamin D you're supposed to get also correlates to the amount of sun exposure you've had. And so, how do you correlate those two factors, right? So you need some sun, but not too much. So, how do you balance that need for vitamin D versus the risk of developing skin cancer? But funnily enough, nothing ever eventuated any of those three spaces. We had a lot of industry conversations. We spoke to a lot of different people. And I think eventually I just told myself, I don't know the market push or I don't know the market need. So I'm happier to work with someone in a more collaborative manner for somebody like an industry partner who has kind of done that research of, okay, here's the need, here's what we desperately need. And then to come to us and we work with them to develop solutions. So that's the way we've just gone with the flow of, who's come to us and therefore we work with them rather than us actively pushing a particular application.
How many people are actually working on this project? Because it sounds like if you've got the idea of being across so many applications, you would think there was a few people working on this.
I haven't even spoken about another cool technology of ours, which is actually a biosensor technology, which is similar to your rat test, right? So unfortunately, we did quite a few different rat tests during COVID, where we were looking at saliva-based rat tests, where you're kind of monitoring whether you have COVID or you don't have COVID based on what your saliva tells you. Your saliva can tell you a lot more about yourself, besides just the fact about COVID or not COVID. Everything which is present in blood is actually also present in saliva. It's just present at concentrations which are like 1,000 times lesser than what's present in blood. So the entire concept there was trying to replace a blood test, not so much replace, but kind of have the ability to look at your saliva in the comfort of your own house and use that as a personalized, diagnostic or medicine tool. So where you can use your saliva to get an understanding of what's happening to your health parameters. So that's another cool technology which we're working with nearly 6 or 7 different industry partners in 7 different fields of use. So back to your question, how large is the group? We are actually a group of around 35 members. Half the group are looking at more the fundamental aspects of the research, which is, new materials, new cool electronics, new devices. And half the group is more focused on working closely with industry and design and manufacturing collaborators to kind of allow a lot of these technologies to take their baby steps out from the lab into real life.
So a lot of the people who are listening to this or watching this, they're coming from either the smart home technology sector or commercial AV. I'm wondering how you see this potentially playing a role in these industries. Is there something that could be done in the home that could be applied into larger control systems or custom electronic systems? Is there anything like that you've either been approached about or think could apply?
One thing which we always look at is trying to create something which is kind of software agnostic, right? Because there are lots of technologies, obviously, like even if you just take the aspect of monitoring, in an aged care setting, for instance, there's radar technology, which kind of, allows you to monitor when someone's falling off the bed. There's other underbed and overbed technology, which kind of allows you to understand, falls and sleep and things like that. There was one thing which I kind of looked at a few years ago, which was looking at patterns within the home, right? So you know that someone gets up and every day they go through a certain set of patterns, right? And once you kind of map that out, okay, mom's got up, she's going through her routine, which is turning on the bathroom light, flicking on the kettle, opening the refrigerator. So there are ways by which you can actually map out a person's patterns and what they do everyday basis. And that kind of then allows you to understand if the pattern's not being followed, maybe something is wrong, and therefore you need to intervene. So there was a pretty cool technology which was kind of almost connecting up all the various smart devices within the house to understand what's a person's pattern every day and when is that pattern being disrupted to kind of indicate maybe something is not okay. It's pretty cool.
Okay. And did you get very far with that kind of research into that pattern mapping?
The entire issue there was kind of the software, because it was every single thing which you use in your house probably has a different kind of a software backing. And so it kind of becomes very difficult to kind of get all the various pieces of information onto the same kind of a dashboard system to get that understanding. That's kind of the same difficulty we sometimes face in an aged care setting as well, because when you try and insert a technology into a new kind of a setting, they go, oh, but we're already using, this software, and we're already using this particular kind of mapping tool. We're already using this dashboard. So how does yours fit in? So as much as possibly try and keep us kind of software agnostic so that it kind of fits into any of those existing ones. But sometimes people are locked into certain particular pieces of, doing things certain specific ways, and that makes it difficult to insert something novel into it.
Did you run into any issues at all around, I guess, privacy or data security? Because I know that comes up so often in our industry now, especially as people try to launch new technologies. It's the first thing people go to. So I'm wondering, did that come up? And I guess in what way? And how did that affect what you were actually trying to do?
It almost always comes up. And the way we handle it is usually our industry partner kind of handles that kind of information, because obviously the easiest thing to do is anonymize all the data and to encrypt all of it. And so they kind of look after those data encryption and the anonymization of those kind of things so that you don't really get a person's details, which can be easily hacked into and things like that. So we try and we work with them to ensure that that's kind of looked after. And we've run some trials in aged care homes as well. So we make sure that, it doesn't give away details. Obviously, shouldn't give away the personal details of a person who's using the tech, but you still want enough detail to kind of create a map of what's happening.
Yeah, and that's always that kind of very hard line to balance on sometimes, where you need the data and people don't always want to give it to you.
It's a fascinating question, and I usually give this example, right? So I remember going and talking about the same aged care Nearable technology in an Asian setting, right? So when I go to Asia and I present the same tech, a lot of certain countries, they just go, that's too complex. Why don't you just put a camera in the room, right? And you'll just get all the information you need. And I just sit there and look at them and go, oh my God, I don't look forward to having that conversation back in Australia. But the idea and notion of privacy and safety, I've realized is so cultural. It's just, it's actually quite funny to me, right? I mean, how much people are sometimes willing to forego privacy for the sake of safety, which is actually very different in an Asian setting, versus how much people value their privacy and, where they go, nope, I don't care. It's okay. Even if something goes slightly wrong, I'll deal with the consequences, but I'm not giving up my privacy, or I'm not giving up, my certain way of doing things. So that thing is actually it's personal, but it's also very cultural, is what I've found, over the last 5 or 6 years with this technology.
I had an integrator on the show a couple of months ago, and she was talking about this very issue and referring to it as value tension. And basically, you can't have both. So something has to give. And it was quite fascinating, because I think once it's got a name and once people are talking about it, they actually realize, you can't have privacy if you want security, for example, because you can have security cameras. Yep. So it's been an interesting thing to watch, and all of a sudden people are actually realizing you have to have a trade-off. But then talking to end users about it becomes completely different, because they don't always understand or want to accept that they have to have a trade-off.
It's also ties in a lot to insurance, who's liable for the decision and things like that. Like even with the aged care Nearables and putting sensors, I remember there was this big conversation of how much does the family get to know or see, right? Because yes, you obviously want to know, but how much are the aged care staff going to, deal with phone calls, just because they also have visibility of data, right? So it's quite a complex setting in that way. So even with the platform where we're actually putting sensors within mattresses, here it's very an aged care focused product, but then we're also developing the same technology as an in-home aging product, because that's what our Asian population has been interested in. So there's been a lot of interest from Japan, from Hong Kong, and from China and from India, where it's not so much residential aged care homes. Culturally, the idea is people age in home, but you still want to keep an eye on, your grandpa or your grandma or your mom or dad. And so instead of the sensors talking to a dashboard in an aged care setting for the carer to have a look at, this is more of where the sensor would talk to an app on your phone. And that kind of allows you to keep tabs on what's happening. Is mom okay? Has she fallen out of bed?
Connected Magazine is your go-to publication for the commercial and residential AV and smart home industry. Choosing products can be overwhelming. That's why Connected features independent reviews in every issue, breaking down performance, usability, and value so you can make informed decisions for your clients and business. Check out this and more in the latest edition of Connected, plus the website for daily AV news and new products. Links are in this episode's description. It's that time of year again. It's time to renew your CEDIA membership. Renew by 31st of January to stay connected, supported, and recognised as part of the global smart home community. Not a member yet? Join by 31st of December and get the rest of 2025 included at no extra cost. Access exclusive education, events, business tools, and the advocacy work shaping our industry's future. Renew or join today at cedia.org/join. That's cedia.org/join. So how are you navigating? Because I know some people, they don't necessarily want to have a wearable. And again, that probably goes back to the fact that they're used to the smartwatches and actually having something physically large on them. How are you navigating that side of things? Because some people are just so hell-bent it's not going to happen.
There is an element of design which we try and bring in really early into the piece. So for instance, we work quite closely with a lot of people from either within my university, or we work from people who are outside from various companies. They do a lot of user mapping for us, right? So they actually talk to the potential users. They try and understand what are the barriers, what would help you embrace this technology. Like even tiny things, right? Like for instance, we developed this ECG patch, which people could wear on their chest to monitor their ECG parameters over a period of time. We made it so small and sleek, but then what we realized was every time a person was trying to insert a battery within it, the entire thing broke, right? So people lack the dexterity sometimes to insert that battery into the battery holder because it is so tiny. So we actually had to make it bigger so that it's easier to insert the battery. So miniaturizing something smaller and sleeker is not always the way to go if you know the person who's going to be looking at the technology lacks the dexterity to actually kind of look at it, right? And the same with all the technologies where we're using apps, because we have the designers talking to 75-year-olds who need to probably look at the app. And then it's a question of if they can't use the app, then they're not probably going to use the technology either, because if it's too difficult to kind of navigate that entire piece. That gives us a lot of insights in terms of what do you want the technology to look like? What do you want it to feel like? When are you comfortable using it? That's why I really actually love the Nearable piece, because it doesn't really require you to do anything. Obviously, the easiest way to gather data from a person is to get them to wear a pajama at night, which is loaded with technology, right? But are they going to wear that pajama every day? Are they going to actually go and wash that pajama and remember to charge the device or whatever, right? So sometimes we have to keep that in forefront of the mind. It can be the best technology ever, but if no one's going to use it, it's might as well need not exist, unfortunately.
Yeah, that's right. And I imagine that's probably where your industry partners come into it too, because they would be wanting to go out and do the industrial design side of it and doing the market research to make sure that what they're going to get involved with would actually then resonate with their potential client base.
The other piece of that is also, where how much data is really useful, right? So when you talk to clinicians, they also say, we actually do not know what happens to certain parameters in the body on an everyday basis. Right. So the clinicians say the best we can ever hope from people is to get a blood test every 3 months or 6 months if you're lucky. If you monitor and give them every second what's happening with somebody, they say we actually do not actually have the knowledge to know, is this normal or not normal? We only look at trends which go over months or years. We really don't have that day in, day out analysis of trends, and obviously it's a lot of data. Somebody has to sit down and look at it and make sense out of it. So it's really the question of, is too much data, is it really necessary, right? And so you don't really need a continuous wearable for most applications. A glucose monitoring, sure, because it's so influential based on what you're eating. But for a lot of other things, everyone thinks it's cool to have a continuous stream of data. But does it actually clinically, does it even make sense? Does actually somebody know whether it means something one way or the other? That's another big question mark.
Yeah, and I think that's definitely become, I guess, more known in the mainstream media, because I know I was reading recently about full body MRIs that executives are having, for example, and all that is just leading to further expensive tests that are completely unnecessary in most cases. So I guess it's probably a similar situation where it's excessive data, and everyone obviously talks about needing data and wanting data because they want to be able to monetize it. But yeah, you're right. And how do they actually use that data in a beneficial way rather than just trying to collect it for the sake of it?
Because most industry partners who come to us, we kind of actually ask them to talk to a clinician first to kind of understand what are those two or three things which is worth monitoring, and how often do they need to be monitored, right? Because having something which is attached onto your skin and collecting data all the time, is it really needed? For certain things, probably for a very short duration, like the ECG, I can see it's super useful for somebody who has just had heart surgery, for instance. If you're just going to be lying in bed monitoring that, but whereas this is going to give you the freedom of actually, recovering and doing things over the 2 week period, sure. But do you need to be wearing one all the time to be monitoring it all the time? I don't think anyone has the time or the capacity on the other end to be looking at all the data and picking up trends. Maybe with AI, one day it might come in, but there's also the lack of, I wouldn't say lack, but there's not really been a lot of clinical backing for the whole thing to kind of come at it from a clinical understanding of what's happening as well.
So, in your experience, in your opinion, how far off are we actually from seeing more of this technology out there in the market and being used in a way that is effective, not just kind of the first adopters who rush out and buy stuff for the sake of it? But are we talking years? Are we talking decades? I mean, when will we actually see this technology?
I would say years, but I would rather you actually wait and get something which has been TGA or FDA approved, or at least has the right kind of regulatory attached to it, which kind of allows you to trust that data. My biggest fear sometimes is that there are so many substandard products which are already hitting the market at a fraction of a cost, which haven't been vetted, which haven't really gone through the rigorous, ways of actually testing it. That sometimes people see it, they buy it, they use it, and they realize that the data is not good enough, and then they lose faith in the entire technology as such, right? Whereas it probably should never have hit the market at that point in time. You probably should have waited for a better product to come. One of the examples was the SIDS monitoring, right? So you get now when you if you as a new parent, if you go to any baby shop, there are a few which are available which allows you to monitor whether your baby has SIDS. And so there's a little device which kind of slides into a cot and kind of allows you to understand what's happening to the baby as the baby is sleeping. Any new parent who, for the first time, most people don't know what they're doing. And so they think, oh my God, fantastic. If there's a tool like this which can help me. The number of false alarms it generates and the number of, just the panicky situations parents are placed in. And then they go, oh, it's useless. And then they pick it up and they throw it, right? So, but I don't think there are actually TGA and FDA regulated SIDS monitoring devices which are actually available in the market yet. And when they are available, they're probably going to come at a higher cost because obviously it's taken that many years to develop it and get it to that kind of regulatory standard. But are people actually going to know the difference between that versus something which is sold at a fraction of its cost, which is not reliable? I don't know. And for me, that's my biggest fear, that we are taking the time. Sometimes we're taking the time to do things properly, but in the meantime, there are a lot of other things hitting the market. And people are always grabbing that in the hope that it'll be something revolutionary and then losing faith in this concept of technology, right? Because it's not reliable. So I'm just hoping there's a better way by which people are educated to make better decisions and place the right amount of faith in the right kind of device.
Is there, I guess, a turning point that you could see, or potentially is there a white whale out there that you sit and go, okay, if we can solve that, that's going to be what really makes this a mainstream technology, or this is what's going to really deliver it?
It depends. It really depends. I mean, and each one is going to be different. Like even for the aged care, where we're talking about putting Nearables inside on the mattresses, it can easily detect is a person in bed or not in bed, right? So that is like the minimum viable thing which we can do for sure. And then adding layers to it in terms of detecting the person's presence, the position on the bed for a false detection piece. And then adding one more layer on top of it to detect their posture on the bed so that you know about pressure sores and things like that. And then adding a layer on top of it to understand, what are their health parameters while they are in the bed, and then their sleep parameters. There are layers to it. I think we can't just hit it with all systems go, but hopefully we build trust as we keep going step by step. And I think clinicians backing it and actually looking at it and making data analysis with that will also be significantly useful. Like even the saliva piece which I was mentioning, if we actually can start using it, I think COVID helped in some ways, right? Because you kind of gain some trust on technology because you could get something like this and make that kind of assessments using that. I think with time, sometimes it'll get there, but it has to be one step at a time.
So I guess from your position then as someone developing this technology, I mean, what would help from here? Is it more use cases from industry partners? Is it feedback from users? I mean, what's going to help progress things from here?
I think our biggest problem has been a lack of continued funding. We get funding, but we get them in bits and pieces. So, for instance, even the one where I mentioned about putting Nearables and sensors within mattresses, we've had three different tranches of grant funding to get it to where it is right now. And we're still in that position where we need more funding to get it to the stages after that. I think we get people who are willing to trial things quite easily. So people do embrace that aspect of it. But just the amount of funding and time it takes, especially for a deep tech product to hit the market, I don't think people have quite understood that yet. It's not like an app, right? Which you can envisage in January and release in June and recover your funding by the end of the year, which a lot of investors are quite happy to invest in because you feel like it's a low risk pathway and you know exactly where it's going. Deep tech takes a lot of time. Even the technology development takes time, and especially if it's a medtech product, it takes even more time because you go through the whole regulatory. So I think a lot more knowledgeable investors who kind of appreciate that this is the amount of time it takes and who kind of come with that kind of knowledge base, that will be super useful. Because sometimes there's a rush to get to market, and that's where you kind of start, making not so great decisions.
So is it a case of there's not enough funding available, or it's too competitive, or is it a combination of both?
I think there's a big push for industries and startups and everybody to, kind of do these things, but there's not enough funding going around. And that's always been the case. But even with investors, there's not so much investment which is available for something like this, which is literally, unless we start today, we're not going to have something exciting in 10 years' time. Again, as a country, I think we've always been more risk averse. And so it's always less risky to invest in an app than it is to invest in a deep tech product. But then if you don't invest, you're never going to get that product, right?
So is this, I guess, a uniquely Australian issue, or do you take global funding? Is it similar from that side where there's not enough funding at a global level as well?
Australia's startup market is quite young, especially in the medtech space and things like that. Globally, like say if you're talking about US and things like that, people are very used to somebody starting up something failing, something moving on. People understand deep techs startups a lot better. I think we are still a lot earlier in the game, and we could borrow a lot of lessons from overseas and not fall and make the same kind of mistakes. Yeah, and I think eventually 10 years from now, we'll all be a lot smarter. But unfortunately, I think all of us are running the same race at the same time. And so learning the same hard lessons this at the same time. So we will have a lot more knowledge at the end of in a decade or so. But I think just taking lessons from other countries and being more aware of the length of time these things take would definitely be helpful. A lot more information has to go around as well.
So I guess for the people listening to this, the guys out there who are integrating technologies into homes or into commercial properties, is there anything they can do now to prepare for when wearables and Nearable technology arrives, or is it still quite early for them to be factoring that into jobs?
Skills is a big thing, right? I mean, even with the aged care, that's one thing which we kind of understood, because we are walking into a lot of aged care homes where there's still pen and paper. And the idea of bringing a computer in and now a dashboard in and then technology in is something which is so foreign. So there is that big reskilling which needs to happen for technology to be embraced into a lot of these kind of homes and aged care homes. And that's something which we actively kind of are marketing for, even because we're always talking about education happening, and it all happens in your 20s and then there's nothing happening after that, right? But the pace at which technology is changing, you kind of almost need micro credentials and upskilling happening all the time. But at the same time, you also need people who are in their 50s and 60s who are probably now need to embrace technology in a way which you never had to think about when they were going through uni to now look at it from a very different perspective, right? So there is that massive skills upskilling which is required for people to even embrace technology instead of being against it. And for me, it also goes back to what I said earlier, which is people actually understanding the nuances between what's regulated, what's not regulated, where can you trust the data, and where can you not trust the data, and not therefore, making assumptions about everything. And then obviously a software piece as well, which is how do you marry off all these diverse pieces of technology into one kind of platform?
For the podcast side of things, so let's talk about the saliva, the bioscanner. What would the full potential be of this technology? Obviously, you can take a lot from saliva, as you mentioned. What would the practical application of that be?
So we're working with nearly 6 or 7 different industry partners on this particular technology. So for instance, one of them is looking at IVF, right? So where women are having to go in to get blood draws so very often, and you're making those trips just to get blood draws done. Can you actually replace some of those blood tests with a saliva test to understand your hormone levels? And so it kind of cuts down the number of visits and the number of anxious, stress related blood draws, especially something as invasive as pricking your skin all the time. We also have a cardiac version of it, which is looking at your risk of developing cardiovascular disease or stroke. So, can you actually prevent that cardiovascular disease from actually occurring by monitoring your levels and therefore keeping a better eye on your parameters? Like you get your cholesterol checked, but how often do you get it checked? If you can actually get a better understanding of what's happening, where you don't have to keep running to a doctor's clinic to get those blood tests done, it kind of allows you to just get a better understanding of the whole thing. For people who are the indigenous populations, one of the biggest things which they develop a lot of is chronic kidney disease. And by the time a lot of them are actually diagnosed, this disease has actually gone to an advanced stage. So something like this kind of allows you to capture chronic kidney disease quite early, but it also allows you to keep a tab on it, right? So you understand, when do I need to go in for dialysis? How often do I need to go? What are my parameters and how am I measuring up? So for me, it's just immense, the kind of possibilities of being able to use something like saliva and measure these kind of values of you, which you would only normally get using a blood test. And obviously, if you have needle phobia, this is, win-win.
And especially if it's using a similar method that people got very used to during COVID too, it shouldn't be a massively foreign concept for them to be able to then use this technology.
Exactly. And we're coming at it also from a sustainability angle, because one thing which we did heavily during COVID is use all those things and then throw the plastic in the bin, right? The amount of plastic sticks which landed in the bin was, oh my God. I think there's actually an artwork which is coming where someone's going to make artwork with all those disposed sticks to kind of show you how much plastic pollution we created during that time period. So with this, because we work again closely with designers, we've kind of gone into the angle of what can be reused, what can actually needs to be tossed in the bin. So we reuse almost 95% of the technology. It's only the sensing strip which goes at the very end, which is changed every time. So kind of keeping those kind of angles in mind as well as we develop technology, I think is super useful, because unlike clinical waste, technology is something which lasts a lot longer, right? Like even the ECG patches which we develop, which people can wear for 10 days, there's no reason to throw that patch in the bin. There is a way by which you can kind of sterilize it, take out the components and reuse it. There's a lot more lesser e-waste being created as well. So trying to, keep that kind of angle in mind as well.
So how do people find out more about your research? How do they follow what you're doing, progress? How do they potentially get involved?
I am on LinkedIn. People usually send me emails and they usually get in touch quite a lot via LinkedIn. The website has a fair amount of information, but I usually do a lot of media talks, media releases, public forum talks, podcasts, and TV interviews as well. I was very early stages of my career was actually funded by the Australian taxpayers' money, right? My fellowship was actually funded by the Australian Research Council. And so for me, it was this thing of giving back and trying to ensure we tell people that your taxpayer money is going towards a good cause, right? It's kind of going back to that. And for me, it's also a big piece to kind of enhance interest in STEM. I'm also co-chair of Women in STEM Australia. So that gender diversity piece where we have so few girls doing STEM subjects is something which is always resonating with me. So I'm making sure that people understand just the wonders of STEM, what engineering can actually allow you to do for future generations, and hopefully attract more of the next generation into STEM.
So tell me a little bit more about this Women in STEM group, because this is something that we've been grappling with from our industry, in that we just don't have enough women coming into the market, even though I've been told apparently we have a higher percentage of women in our side than we do in other electrical trades. But at the same time, it's still a very small percentage. So what is the group that you're part of all about, and how does that work?
So Women in STEM Australia is actually not for profit. So I've been co-chairing it for the last 3 years, but we've actually existed since 2014. The entire idea there is to connect up women across different sectors in STEM fields because we're so few in numbers. But at the same time, it's also to do advocacy on behalf of the women for, just one, obviously for more girls and women to enter into STEM, to have better thriving careers and to rise into leadership positions because there are quite a lot of barriers at every stage all through the entire journey. The Girls in STEM piece is actually kind of trying to make sure that girls make better, more informed decisions about their careers. Unfortunately, there's no engineering subject in school. And so a lot of people don't really know what engineering means, or they think all engineers are civil engineers and therefore work at construction sites. And so that understanding of this is what you do when you're an engineer, there's so many different branches to being an engineer and things like that is what we're trying to create more awareness of. I'll be honest, unfortunately it's been quite slow in terms of the entire progress in this particular piece. I was part of a decadal plan which was done by the Australian Academy of Science around in 2018 2019, and obviously I come from India, so I'm a migrant Australian. I came here in 2004. The number of girls who do STEM in India or China is actually 50-50. So there are no issues over there as far as
Wow.
entry is concerned. I grew up surrounded by engineers and thinking that, of course, I can be an engineer if everybody around me is an engineer, right? So it was never even a mental thought process that I would not be good in maths and hence I cannot become an engineer or that my gender is a barrier for me. Here, it's a very, very different kind of thinking. So it actually took me a good few years to even understand why is it so different, right? There's so much of it is cultural and there's so much of it is just peer pressure related as well. And so somewhere we need to break down those silos of where girls start doubting their skills in maths or start not seeing themselves in certain careers because they just think they're not good enough for it. And somewhere that entire silo piece, the teachers, the careers counselors, there are so many bits and pieces involved in the whole thing. But we also realize we do a lot of targeted efforts at the primary school level, but we don't actually evaluate it at every stage. So, that one-off engagement at certain levels doesn't really help, right? So it almost, how do you make sure there's a sustained level of information going through for them to make more informed decisions about their careers, I guess. Long way to go. Yep.
Have you found that schools have been receptive and have they been kind of supporting the message? Because this is something we've run into and trying to encourage females to move into trades. And that is schools only want to talk about universities. They don't want to talk about trade at all. And then they already seem to have this preconceived notion of where they want to send kids without even talking to them.
It's a challenge, I'll be honest. And we've had some schools who engage, but it really depends a lot on that individual science teacher or the individual careers counselors. I don't think it's like an all out approach, right? So we've had instances where we've reached out to some schools and they've literally gone, our curriculum is full. We don't have time or space to, incorporate you or to add your entire thing in. Whereas there are some schools who actively seek out scientists and actually reach out to them and say, we're doing National Science Week. Can you come and, talk to our kids about this? So it's still very, very individualistic. It just depends on that right person sitting in the right place at the right time who can make a lot of positive change. But if those stars don't align, unfortunately, nothing is changing.
And it's sad to watch when
for sure.
We all need people to get into these technical industries and yet they're just not being told what the opportunities are.
It kind of goes back to funding again in some ways, right? Because some initiatives are funded, but they're funded like for 2 years or for 3 years. And then you don't ever see, obviously, if I influence a year 5 student in a positive manner today to become an engineer in the future, she is probably not going to be a data point for at least a decade, right? So, and that is not something you're going to measure in a 3-year grant period. So there needs to be better way of evaluating it, but also better ways of just sustaining that entire thing of how do we start young and keep that interest and keep it going. So that I'm not saying everybody has to become an engineer, but I just want people to make more informed decisions about their careers without assumptions. And that is something I don't think, unfortunately, we made too much traction on.
Yeah, absolutely. I don't envy the people who are trying to see that shift happen, and it's going to be an uphill battle, which is a shame. With that, I guess we've come to the end of the end of the episode. So I do want to say thank you so much for joining me. I really, really appreciate you taking the time and talking about what you've been developing, and then obviously the part at the end there with women in STEM, because it is a massive issue. yeah, so hopefully we can see some traction there and see.
Can I tie the two together? Because
Absolutely.
another thing which is fascinating for me is technology which is made as one size fits all, right? So we also kind of make sure that we keep this diversity in mind when you're designing technologies. Like my favorite example is when we developed UV sensor for a company who basically just wanted one UV sensor, right, to monitor UV levels at exposure to a person's UV levels, and therefore alert them of when they need to go and put on more sunscreen. We actually didn't develop one UV sensor for them. We actually developed six because there are six different skin types. And we realized that one UV sensor is not going to cut it. So thankfully, I lead quite a diverse group. So I kind of looked around my table and I realized there are four different skin types just around that one table. And we all therefore need different levels of UV. And it's kind of going back to the vitamin D UV kind of relationship. Same thing with, developing technologies for women where, I used to work in clean rooms, for instance, and I used to wear these very ill-fitting clean room gowns, which probably are more of a trip hazard than they are protecting me. And so a lot of things are being designed for men by men. And so where do you bring that entire piece of, and especially going forward as we start designing new technologies, it's really about how do you make sure it caters to the diverse audience, right? So my favorite thing is like this phone where, a woman's hands doesn't quite navigate the phone the same way a man's hands does. And so, that's because it's designed for a male hand, right? And so you don't design it for a woman by making it pink, but you actually need to design for their hands, keeping their hands in mind. So there is that huge thing as we keep going forward, and the bias and the AI and everything which comes in as well, which really has to take into account, I guess, just the diversity of the audience, not just gender, but culture, age, everything.
And that has definitely been a significant problem, because I remember the one that I heard about was the hand dryers that didn't recognize dark skin. So it just didn't turn on if someone who had, black or brown skin put their hands under there, it wouldn't activate because it didn't recognize there'd been hands there.
Fascinating. Wow. Okay.
Yeah.
Yep.
So that is definitely a significant issue that I think there's obviously some people like yourself who are very aware of that and are factoring that in, but I think there's still a long way to go on that front as well of making sure that it is considered at the initial design stages rather than leaving it too late.
Yep. True.
Yeah. I mean, thank you again. Yeah, really, really appreciate you taking the time, and it's going to be interesting to see where the technology heads and how it's adopted, especially within, for our listeners, where it goes in homes and things like that. I think that'd be quite interesting to see.
Thank you, Paul.
A huge thank you to Professor Madhu Bhaskaran for joining me today. Her work is a powerful reminder that smart home technology isn't just about automation. It's about care, dignity, and designing for real people with real needs. Whether it's a Nearable in a mattress, a saliva biosensor, or an ECG sticker, this is the kind of innovation that will shape the future of aged care, healthcare, and well-being in the home. If you've got thoughts, feedback, or questions, I want to hear them. I'm also looking for stories. Have you worked on a life-changing project, tackled a unique challenge, discovered something we should all know about? Email me at info@masterintegrator.com.au or send me a message on LinkedIn. I'd love to feature your story or your suggestion on an upcoming episode. Thanks again to our sponsors, NetVio, Coliseum, Connected Magazine, Integrated Systems Europe, and Cedia for their continued support. Thanks for listening to Master Integrator. I'm Paul Skelton. I'll see you next time.